The principle of electric motors that you didn't understand in a year of school. I'll explain it to you in 3 minutes. Put two magnets together and you'll see that they attract at opposite poles and repel at the same poles. If you take one magnet, punch a hole in the center and put it on a stick. And then you take the other magnet and you put it close to it. The magnet on the stick will rotate to the pole of attraction. All we have to do is change the pole of the other magnet to get the stick magnet to rotate again. But that's too much work. So we take out a metal bolt and we wrap some wire around it. Then we connect the two ends to the positive and negative poles of the battery, and the current flows through the wire, forcing the magnetic fields to line up. This turns the bolt into an electromagnet, which has positive and negative poles, just like a magnet, and can attract and repel other magnets. If you flip the battery over to change the direction of the current, the positive and negative poles on the bolt will flip over as well. But swapping wires is easier than flipping a battery. Now we'll attach the bolt to a stick and put a magnet with a different pole on the left and right side of the bolt to enhance the effect. So the bolt would keep spinning, but we'd still need to keep swapping wires. So we came up with a better idea. We replaced the small magnets on each side with larger curved magnets. Then we replaced the bolt with a metal armature and fitted it with a commutator that had a gap in it. With the commutator, we didn't have to keep switching wires back and forth. Then we add brushes on both sides of the commutator and connect the wires to it. When the power is turned on, current flows through the armature to the other side of the brushes, turning the armature into an electromagnet that starts to rotate. When the rotating commutator and brush contact surface changes, the current will flow in the opposite direction to make the electromagnet switch polarity. After solving the tedious problem of switching wires back and forth, we can add another armature circuit to make the motor spin even faster. Theoretically, the more armature circuits we have, the faster the motor will rotate. So the rotational force on the armature is also called torque. Now we change the metal armature to multiple armature coils to make it more magnetic. And now we have a complete DC motor. It can drive electric toothbrushes and fans and electric cars and most other things that need to spin. So after watching this, tell your classmates who are still in the dark.